formulas. So let me explain the chord formulas to you. If you have a circle and you have a chord, remember a chord is just connecting 2 points on the circle, okay? And then you have another chord, okay? Not going through the center. That's not the center, okay? That's not the center. Okay, so you break it up into pieces, A, B, C, and D. All right? If you play with the algebra for a little while, all right, and the geometry behind it, you end up with formulas like this. A times B is equal to C times D. That is true, okay? So that means if I have two chords, right? And this is, I don't know, 3 and 6. And this is 2, and I call this x, and I ask you to solve for x, right? All you would have to do is you'd have to do 2 times x is equal to 3 times 6. What am I saying? I'm saying this piece times this piece is equal to this piece times this piece. All right? So you get 2x is equal to 18, so you get x is 9. So 2 times 9 is the same as 3 times 6. Those are typically really easy to do, right? Because it's just some kind of simple multiplication. But that's the first chord theorem. If you don't know that theorem, you should be writing it down, okay? The second chord theorem, all right, is what happens when it gets cut by a secant, okay? Once again, the pieces get cut off, like A, B, C, D. Let us get this out of the way right now. These are the hardest problems for chords, these types of problems. It is not A times B is equal to C times D. No, not true. Okay? Somebody that I taught, yeah? So, or somebody who knows this. What's this chord theorem?
A times A plus B is equal to C times C plus D.
Good job, buddy. So A times A plus B is equal to C times C plus D. I'm going to teach you a better way to think of it. Watch how I say this. The outside times the whole thing is equal to the outside times the whole thing. Look, the outside times the whole thing, outside times the whole thing. Okay? That's it. That's the second chord theorem. Okay? So if I had this, I had one like this, and I said this was, I don't know, 4, and this was 6, and I said this is 2, and I said this is x. All right, I'm going to show you a way to do this problem and saving yourself a little bit of work, okay? The formula says the outside 4 times the whole thing is 4 plus 6, right? Is equal to the outside 2 times the whole thing, 2 plus x. But here's what I like to do here. Megan, this will be a good one for you. Megan, you there?
Yes.
All right, so we have this part right here. You see how this turns algebraic where we have to distribute and all that?
Yes.
So what we do instead is we think of, instead of thinking this as 2 plus x, we think of this as y.
Okay.
Because once we can figure out what y is, we can figure out what x is. And then we keep ourselves from having to deal with extra algebra. And even better, sometimes it keeps us from having to deal with quadratics. So think of that as y instead of 2 plus x. Okay, let me stop there for everybody. Does that make sense? If the outside's 2, I'm calling the whole thing y, and then I'm going to figure out what y is. And once I know what y is, I can figure out what x is. Thumbs up if that makes sense. Okay, so back to you, Amber. Or Amber, that's funny. Megan, 2 times what then?
2 times y.
2 times y, yep. So this is y. Okay, so what do I get, guys? I get 4 times 10 is equal to 2y. So divide by 2, and I get what 40 over 2 is. So y is 20, right? Now, if y is 20, Megan, then what is x?
We would do 18.
18, exactly. So that's 18. Okay, stop there. Does everybody understand why it's 18 and not 20? If you don't know, go ahead and speak up. It's okay to ask a question there. Okay, so that's the second chord theorem, okay? The outside times the whole thing is equal to the outside times the whole thing, okay? All right, then we have a third type, everybody, where you have a secant, but you also have a tangent, okay? So like that. Pretend that's a circle. I don't know what's going on there. All right, so then we get A, B, and C, right? Now, what I like to do on this problem is I don't think of it as a new formula. I think of it as this formula, yes? I think of it as this one, the outside times the whole thing, because watch this. The outside is A, the whole thing is A. So we're saying A times A. The outside is B, right? The outside is B. The whole thing is B plus C. So B plus C. Okay, stop real quick. Does that make sense that I don't have to memorize a new formula for this? I can just do this. The outside is the whole thing, so it's just A times A. So that's A squared equals B times B plus C. And that's the third type. Yeah? There is one more type they do sometimes, but this one's actually really easy. Somebody who's not taken geometry yet, what if I had two tangents?
You could just do the other formula.
Right, but go through that. But hold on, go through that formula real quick. As you go through the formula, something should dawn on you.
Squared. So A
Equal?
They're equal. That's right, because the outside A times the whole thing A, you get A squared. And you get the outside B times the whole thing is B squared. If A squared equals B squared, then that means A equals B. And that is true, okay? When you have two tangents, the tangents will be equal. All right, so there's the four formulas, right, for chords.